In the last video, we introduced if statements. If statements are a way to control how your program behaves. If something is true, do this. If something is false, do something else. Now, as part of all if statements, you need to have a conditional, right, to check something. Now, the simplest conditional we might have is just a comparison to see whether two things are the same, if they're equal. Now, there are a bunch of different types in Java, so it turns out that there are actually a few ways we can compare things. And that's what we'll talk about in this video. So the first thing we can compare, which is going to turn out to be the simplest thing we can work with, is integers. So let's write a short test program to do that. So I'm going to start by creating two variables, a and b, and giving them some initial value. Here I have a as 10 and b as 50. And then I'm going to write an if statement to compare them. So I'll write a equal b. Right? This is called the equality operator. So this tells Java, check to see whether a and b are the same thing. So if they are, let's make it print a message. We'll have it print out the message saying that a is the same thing as b. Now if they're not the same, right, if that conditional ends up being false, then I'll have it print out something different. So I'll put in an if statement, meaning something that should be done if that expression is false, and then another print. And this one will have slightly different text. So if I compile and run this, I should get the message back telling me that a is not the same as b. And indeed, that's what I get. A is not the same as b. Now I could go and change a to be 50. Compile it, run it, hopefully I get the other message. And yep, that's what we get. A is the same as b. So for integers, comparison is pretty straightforward. All we need to do is use equal, and we're good. So the next thing we should talk about is how to compare floats, which is going to be a little bit more complicated. So let's quickly edit our example here and make it use floats instead of integers. I'll change the types from int to float, and then I'll change their values. So for example, let me set a now to be 1.1 and b to 1.5. Now you'll notice there that I put the letter f after those two numbers that I redid. That just lets Java know that those are supposed to be floats. If I don't put an f there, it's actually going to see that decimal point there and assume that that is a double. Unfortunately, I don't want a double, and Java will complain if I try to store a double into a float. Putting that f there just says, yes, indeed, I did mean to declare a float, and then Java will let me store it into that variable properly. So if I run this, I should get the message telling me that a and b are different. And that's what I get. A is not the same as b. Now let me edit these, and let's go 1.1 and 1.1. And this should give me the message telling me that they are both the same. And that's what I get. So right now it looks like floats work pretty much the way integers do. Unfortunately, that's not really the case. The issue with using floats is that arithmetic on computers is approximated. Think about it. Some numbers have a lot of information in them, right? Maybe they have 1,000 digits after the decimal place. That's a lot of information. Unfortunately, computers can only store a certain amount of data, right? Variables are only so big. So let's think about a very large program that has some computation to calculate a and b. It has a whole lot of math going on, and then in the end, you get two different values. So let's say the first part of the program computes a, and really, right, if we were to do a maybe on a piece of paper, we would get 0.1. But computers are doing an approximation, so maybe you get something else. Maybe you get something like this. 0.1, bunch of zeros, 1, and then an f. Right? So this is a number very, very close to 0.1, but it's slightly off since computers do all math as approximations. Or I should say all real math as approximations. And let's say another part of your program is also trying to compute b, right? Maybe it's trying to compute these two things and see if they end up being the same. And b as well should be 0.1, but because it's actually an approximation taking place, it's going to be a slightly different value. For example, this. .0999977, right? So this is also a value that's pretty much 0.1. Unfortunately, it's not being stored as just 0.1. So these are both reasonable values that could be computed by calculations that should have given me the same thing, that should have both given me 0.1. But again, it's an approximation, so they're not the same. Well, if I compile this and run this, we're going to get back the message saying that these are not the same. A is not the same as B. So this is an issue, right? Really, these should be treated as being the same thing. But because we're using the equality operator here, the double-double is checking them exactly, right? It's going to check them exactly, and it's not going to care that they're very close. It's just going to see that there's a little bit of difference in those final digits, and then it'll say, oh, this thing is not the same, that this thing should be false. So how do we fix this? Well, what we really want to do in Java and in most programming languages is to compare the difference between A and B, right? So this is going to happen for most floating point values. What we'll do is we'll take A minus B and see how big that difference is, right? Are these very close together or are they very far apart? So here what I'll do is I'm going to take their difference, A minus B, and then to make my life a little easier, I'm also going to use the method to get the absolute value of a number, which is going to be built into Java. It's math.abs. So this here, right, is getting me the absolute value of the difference between A and B. Once I have that, I can check if it's less than some threshold. Some threshold that tells me, oh, these two things are the same. So here, this code I've written is going to compare those two floating point values, check to see if their difference is small. Because if their difference is really small, that means that they are pretty much the same thing. Maybe they are a little different, but it's just some sort of a rounding error or computation error that's being involved there that makes them look different. So let's go ahead and compile and run this. And if it works properly, I should get back that they are the same. And that's what I get. A is the same as B, right? So now these two values can be seen as being the same because I'm letting them be a little bit different, right? Now I could also change these. Let's say maybe I change this to be 0.0899999. Let's try running this. And you can see this works as well. A is not the same as B, right? Because A is 0.1, B is essentially 0.09, and those two are different. So you can see that that still works as well. So this is just something you should keep in mind whenever you're comparing floats. Really what you want to do is compare their difference rather than just checking to see whether they're equal. Of course, we can store more than just numbers in variables. There are various other types. For example, characters. Characters are a way to store letters inside of variables. So let me edit my code here, and I'm going to change these from being floats to being chars, right? To being characters. So in A, I'm going to store the letter C, and in B, I'm going to store the letter D. And you may notice here that I'm putting the single quote around that C and D, right? So that indicates to Java that this thing here, that's a character, right? And that character is going to be stored into B, right? So the variable's name is B, and its contents is D. Over here, the variable's name is A, and its contents is going to be C. Now, I've redone those, so let me go ahead and also edit my if statement. So I'm going to write in here A equal B, right? So check to see whether A and B are the same thing. Hopefully they're not because C and D are different letters. So let's compile and run this and see what we get. Well, the result is a message telling us that A is not the same as B, right? So that means that the thing stored inside of A, C, is different than the thing stored inside of B, which is D, right? And that makes sense. C and D are not the same letter, so we get that message. Now, one of the nice things about Java is that we can compare not only if two characters are the same, but how they are ordered in terms of the alphabet. So for example, I can check to see whether whatever is stored in A comes after whatever is stored in B. I can do that using the greater than operator, right? So is the thing in A greater than B? So let me update my messages here. And now I have these messages here that say, oh, A's letter comes after B's, or A's letter does not come after B's. So let's compile this. And hopefully I should get back that A does not come after B, right? Because I have C versus D. Let me run this, and I get the message back, A's letter does not come after B. Right? So it's showing me the order of those letters. Now if I change this, if I, for example, change A to be Z, I should get the other result, telling me that indeed A's letter comes after B's. And yep, that's what I get. A comes after B. So one thing you might be wondering about is how Java knows what the order of the letters are. From our perspective, we've just been pressing keys on the keyboard. But how does Java know that D comes before Z, right? Or Z comes after D? How does it know that? Well, it turns out that in Java, all of the characters you type in are actually mapped to numbers. And so there's actually a chart here, and I'm actually going to bring it up really quick. This is the Unicode character table, and this is just from a website I found on Google. And for every letter that you could type on your keyboard, or any other keyboard for that matter, there is a number associated with it. So for example, the letter A is associated with the decimal 97. D is associated with decimal 100. I is associated with decimal 105. So behind the scenes, all of the letters you type in have some number that's associated with them. Well, what happens is that Java, when it sees that operation saying greater than, it's going to go and look at this chart and compare those numbers, because those numbers are showing you how those letters are related. So it can compare those numbers, and it'll be able to see that D comes before Z, right? Because D has the value inside of 100 versus Z is 122. And that's how it knows what order they're in. So the last thing we want to talk about comparing is objects, which is going to turn out are the hardest things we can compare. So let me start by coding up kind of a little bit of a longer example here. We're going to start by completing this class here, right? So I want to have something that I can actually try comparing. So in this class, which is just called a simple class, I'm going to add two variables. I'm going to add a string called name and an ID, which is an integer. I'll also go and add in a constructor to initialize these two pieces of information. And the parameters for this are just going to be that a string and an integer that I can save into my attributes or my instance variables that I created. So I'll go name equal n, ID equal I, just to store those two pieces of information. Now I'm going to jump back over to my main, and I'll create two different objects from this class. First one's going to be called C1, and I'll maybe give that the name AA and the ID 40. Then I'll go ahead and create a second one. I'm going to call this C2, and I'll call this one BB and give it the value 80. Let me also add in an if statement here to check whether these are the same. And for now, I'm going to do it the same way as I would check a number. So I'm going to use the equal symbol to just check to see are these two things the same. If they are, I do want to print out a message that says, oh, they are the same. So C1 is the same as C2. Else, I'll print out the message telling me that the opposite is true. That C1 is not the same as C2. So I can compile this, run it, and hopefully I get back the message telling me that they're different. So C1 is not the same as C2. So far things look straightforward. Consider what happens if I go back and I change C2 so that inside of it stores AA, and 40. Compile it, and let's go to run it. But before we do, let's think for a second. If Java was perfect, right, we might expect that this thing will return C1 is the same as C2 because it's comparing AA, comma 40 with AA, comma 40, right? Well, it turns out that isn't the case. C1 is not the same as C2. And that's because object comparison works a little bit different than just number or character comparison. You see, what it's comparing is not really the information inside of the class, but it's comparing the address where that object is being stored, right? So C1 and C2 are different objects, right? I've used the new command twice. I've built two different things. Well, when Java looks at C1 and C2 and has that equal going on, it's going to see that C1 and C2 are stored in different places. Therefore, Java says these two things are not equal. So in general, you just have to be careful, right? You cannot use equal by itself to check to see whether these things are the same. Normally what happens is that people implement what is called an equals method. So you can actually have your own custom method inside of a class that tells Java, oh, when someone checks to see whether these two classes are equal, this is how you compare them, right? So we could write something called an equals method, and that would go in and actually check to see whether the ID and the name are the same between two objects. And if it is, then that thing would return true, letting Java know these two things are equal. Now, we haven't implemented this special equals method, so Java is just left relying on, do these two things have the same address, right? Are they the same object? One thing we could do if we wanted to just see when objects are equal is to rewrite our C1 and C2 up here. So let's say we could change this to just C2 equals C1. This time, instead of having two different objects, right, having two different new statements there, we actually just have one object, right, which was first created on that line for C1. And then that second line, C2, right, that equal sign there, it's not actually creating a new object. What it's doing is it's just copying the address of that object, right, from that one that was created for C1, and it's putting that address into C2. So we have two variables referring to the same object. Now if we run this, we should get the message that they are the same because they have the same address. And indeed, that's what we get. C1 is the same as C2. A more specific case of comparing objects is when you're going to compare strings. So let's add this really quick. I'm going to go ahead and delete actually my extra information I had from that class I invented. Then over here, let's go and create a string, and we'll still call it C1. I'll go string equals the word the, and then a second string called C2, and we'll put the word not. Now, let me try running and compiling this. I'll get back the message, C1 is not the same as C2, right? So those two are different. Now, based on what we said a couple minutes ago, those are different because C1 and C2 are stored at different addresses, which is true for now. But now notice what happens with strings if we make them have the same thing inside. So let's go change this to be the and the. Compile, run, and now it tells us C1 is the same as C2. So this maybe you did not expect, because what we just said is that every time we create an object, it ends up being stored at a different address, and when Java goes to compare things, it looks at the addresses and sees they're at different places. Well, Java has some sort of special mechanism for strings where it only creates strings one time. So on that line C1, when that line is executed, it's going to create a string object somewhere that contains the word the. But then on that next line for C2, C2 should also store the word the. But on that line, Java isn't actually going to create an entirely new object in memory to store that word. Instead, Java realizes that the word the, there is already an object out there that stores that information. So instead, it'll automatically link that C2 variable to the string object that was created for C1. So really, inside of Java, because these two are the same, it'll actually look like this. C2 equals C1. Again, the reason Java is doing this is just to save memory, right? Strings kind of can take up a lot of memory, and there's really no reason why you'd want to have multiple strings that have the same information inside them. Once you create it, let's just reuse it whenever that same word, that same line comes up throughout the rest of the program. So this is kind of a neat feature of Java, and because of this, we can actually compare strings using the equal operator.